In this video, we will look at an abstract algorithm to implement the least cost search for branch and bound technique. This algorithm is known as control abstraction for LC search. This algorithm takes a parameter known as t, which is the state space tree. This algorithm searches for an answer node in the state space tree t, and within this algorithm, we will first check if t, that is the root of the state space tree, is the answer node. If this is true, then we will output t and return. Then we will assign t to a variable e, which will be the e node. Then we will initialize a list of live nodes, which will be initially empty. Then we will have a repeat until loop, and within the repeat until loop, we will have a for loop for each child x of e node, and within this for loop, we will check if the child x is an answer node. If this is true, then we will output the path from answer node x to the root t of the state space tree and return. Otherwise, we will add the child x to the list of the live nodes, and in the next statement, we will store the pointer for the path to the root using the statement x arrow parent, that is x parent is assigned e node. Then we will check if there are no more live nodes. If this is true, then we will display no answer node found and return. Otherwise, we will call the least function and assign the least cost node as the e node. So this is the least cost search algorithm known as control abstraction for LC search. What control abstraction means is that the flow of control for the approach is defined in the algorithm, but operations or functions, that is add and least, are left undefined and depends on the problem being solved. So this is the control abstraction for the LC search for the branch and bound technique.